Alright guys, Mr. T here, helping you out with the next video. This should help you with exercise 7b.2. Hopefully it's revision, but if not, that's the whole point of this thing, okay? So, in all these problems in 7b.2, you're going to be using area formulae, and you're going to find these on page 180, 181. There's another one by itself on 182 for ellipses of your 11th general maths textbook. So I'm not going to go and do an example of every single one of those. I'm just going to give you a general rule of how to use those formula, and that is basically you need to identify the shape in your question and you need to use the correct formula for that shape, okay? And how do you use the formula? You substitute the known values in. So an example of that is this. Find the area of this triangle. Obviously I have a triangle here, it says in the question, the drawing is a triangle, and it gives me 5 centimeters for that vertical line, 10 centimeters for the horizontal line. And so if you look at the formula, the area of a triangle is half times by the base times by the height. And this is where I'm talking about substituting the known values. Well, I know half, so that remains. I know the base, which is 10. I know the height, which is 5. So it's going to be half times by 10 times by 5. If we go with 10 times by 5 first, it's 50 times by half is 25 square centimeters. Okay, so that's just a really basic example of how you plug numbers in, substitute the known values into the formulas that you're going to find on those pages in your book. Now, the one where I will be trying to help you with is compound shapes. Do a bit more in-depth example here. We have to deal with this because you cannot have a you can only have a formula for the regular shapes. You can see it already takes up 3 pages in the textbook. It'd be ridiculous, and you could not possibly have an area formula for every possible shape that could ever be made, because that would be infinite, okay? So when you're messing with compound shapes, right, you need to break them down into the known simple shapes that we have formulas for. Alright, use straight lines, break them into triangles, break them into rectangles, break them into circles, right? But you cannot work out, say, the shape of imagine if the sides were all straight. You don't have a formula for that L sort of fat shape there. You do have a formula for a larger rectangle and a smaller rectangle, right? So that's what I mean by breaking it up into smaller pieces. Now here's an example here. Find the area of the shaded part. Obviously the overall shaded part is a rectangle, and we have a circle that's not shaded, so it's missing from it. So when you do questions like these with the compound shapes, you should always label your working out with the parts so you don't get lost. Area rect, standing for rectangle. The area of a rectangle is the length times by the width, the length being 10, the width being 8. So that's going to be 80 square centimeters. Now, we need to work out the area of the circle. The area of a circle is pi times by the radius squared. Unfortunately, we don't have the radius, but we do have the diameter, and we know that the radius is half of the diameter. So the radius in this case is going to be 1, and that's going to be squared because it's pi times by the radius squared, and that's going to be 1 squared is 1 times by pi, which is 3.14 to 2 decimal places. Okay, and so now you just have to think, do I need to add these? Well, the circle is white, it's not shaded, so it's an absence of area, so it's actually going to be subtracted. So you would write for the answer area, you could say area total of the whole compound shape. That's going to be 80 minus 3.14, and that is going to be 30 minus 3.14, 76.86 square centimeters to 2 decimal points. Okay, so hopefully that'll help you out with those problems in 7b.2. That's just a simple example. It's going to get you to do more complicated ones. All you need to do is split those complex shapes into the known shapes, using straight lines and you'll be fine. Okay, so I'll see you in the next video.